we want to make sure is the magnitude of, in terms of the magnitude of sigma 1, sigma 2 is still falling into the two, the ranges here. So we are trying is we try to take, we call the combinations of many trials. One example is this. Say, let me take the, say, a point is, say, here, and that is the sigma 1 positive. The other point is here. Okay, for the 2 points, basically we can make a circle. Okay, and repeating the selections of many points, for example, here and here, we can make a circle. And then here, here, etc. So eventually, in between, we would have many such selection of circles, and that circle, if you would trace the boundaries, then that boundary will help us to cover the envelope in between these regions. Okay, so you know what I mean?
How are you choosing those points?
Yeah, so here right now we're talking about the scenario 3. For scenario 3, as long as we pick any numbers, here for scenario 3, we pick up is have an opposite side. So here we, for example, we pick as long as those values are under, they have a smaller value than this one. For example, here we pick this one. Let me draw. How about let me draw this one? How about let me pick this point and this point, and let me draw a circle like this one. Using the 2 points and as a diameter, corresponding circle will be something like this. Okay, and how about this? And then I pick this point, and then how about this point? So using the 2 points, and then I have another circle as a diameter, so that circle is something like this. So we can make many such options as long as we pick the 2 points. One is on one side, the other one is on the other side of this vertical, of this axis, and then we form a circle. So many such circles that would have with just tracing the boundaries here. Then let me put that one. So here you could maybe need a little bit imagination. So that curve basically is to trace the envelope of such many circles. Okay, and this curve is not mathematically expressible. Basically, that is tracing all the situations, but that's the curve here. And this curve should be symmetric for the upper portion. So as long as, so that means here for the scenario 1, 2, 3, basically cover all the possible scenarios for our 2-dimensional stress components. So that means right now we have such an envelope, and then the envelope is composed by this profile. As long as your loading condition falling into this region, then that is safe.
So what's preventing you from having a circle just from UC to UT?
This one to here, to
yeah.
here.
Yeah, because
Oh, that is
point on either side, and the baseline would just be that circle.
Right.
That is the, would that be possible?
That's what I was wondering, how the points were chosen.
Let me think.
It would probably depend on the material, right? Because some materials can take more compression and tension. So depending on your numbers, certain compression and tension.
Um, I haven't thought this before, but let me try this way. If I try to draw the similar range like in that domain, so this is sigma ut and sigma ut, and this is sigma uc, sigma uc. For the scenario one, let everything compressive, and that is in this boundaries here. Okay, so for scenario one, basically corresponding to is this circle. This circle covering is all the possible points that falling into this range. For example, this point, that means corresponding is the data point here. And for example, here, this point, one value sigma 1, 0, you see equal to that one. So for that one, corresponding is this biggest circle, right? And for scenario 2, that corresponding is this range. This curve corresponding is certain kind of the empirical curve like this one here. And that is what I expect to deliver. And now the question is, what happens if we have a data point here?
No, I was just wondering how you chose.
Yeah. So for this one, this point on this one basically corresponding is this circle. Let me use this one. So for this question is if we have sigma 1, sigma 2, for example, is sigma u t and minus sigma uc, what happens? Right. I think that is your questions. So for that one, I think the circle
Okay,
corresponding is the green one here.
Yeah.
Definitely, be honest with you, I didn't think about this before. But definitely you can see the green one, of course, that is beyond this range. Okay, this one beyond this range.
So there's going to be some sort of governing principle for defining that range, right?
I don't know. Please come. Because I took the series so easy. Be honest with you, I don't know. Okay.
For scenario
Yes.
3, though, you're saying that your sigma 1 is positive and your sigma 2 is negative. But the problem is they would have to be like, when you put that member in tension, it has to break at the same point that if you put it in compression for them to equal. Because if you had your tension only did 50 megapascals and your compression only did 80 megapascals, then you could only go from 50 to 50. You can't go from 50 to 80 like that for your circles.
For general materials, and it's sigma ut is ultimate stress due to tension. Usually, we're assuming is not equal to the ultimate stress in tension.
So you wouldn't be able to draw that whole circle for scenario 3. Because you pick one point and then you just take the negative of the other point.
So that means right now we kind of arguing that this condition, this scenario would not be possible, would possibly exist. So
Well, it
that
would
is
be
the
possible,
question.
but one would be 50, one would be 80. It wouldn't be one.
So one is
circle like-
50, one is minus 80.
Yeah, so
right?
you wouldn't have a whole circle like that. You know what I'm saying? Like, it wouldn't, you couldn't go from OUT to OUC because that's the maximum, right? If your maximum compression is greater than your maximum tension with your circles there. So there's no way you could go from one to the other if you're taking scenario 3.
for this green line, for example, this point, for this point, it has the certain, the normal stress, sigma is less than 50. For example, here we take the 50.
Mhm.
And the tau is greater than certain value.
But scenario 3, aren't you just taking the 50 and then making it negative 50 for the other side? So you can only go to negative 50 is your max you could go to.
Let
I
me
don't think they have to be
this one.
opposite in magnitude, just
I thought
opposite
they were
in.
opposite magnitude too.
No, just opposite in sign.
Okay. That's all, there's no way you can.
I don't know the answer, okay, and I need to read more.
Yeah,
Okay,
there
but
has to be some constraint,
Yeah.
otherwise you could just do that.
Yeah, so I need more time to think about this one. Okay, so so if we continue based upon the theory, basically is picking up is the taking this profile. Okay, and let me continue to finish this one. And usually this curve is there's no formulation to predict this curve, and the most of the time the people try to approximate is in the way you based upon the scenario 1 circle and the scenario 2 circle, you simply draw a tangent line. You simply draw a line tangent to both circles, and this one used to approximate this curve. And for that case, basically that linking into is corresponding to this would be the straight line. Okay, so this is a straight line. And using this straight line, that'll be easier to, in terms of the applying to the calculations. For this straight line, for this equation, that equation can be described by sigma 1 divided by sigma ut minus sigma 2 sigma uc equal to 1. So that means here is you can use this criterion. For example, say okay, so using this condition, say for example, if say we have ut say 50 and we have uc equal to 80. Okay, and now for any application, so for example, if you have sigma 1 equal to, and let me make any number. For example, here this would be say 40, and you have sigma 2 equal to say 75. So we see what happens. So simply we plug into this formula. So sigma 1 divided by sigma ut minus sigma 2 and sigma uc will be equal to 40 divided by 50 and minus 75 divided by 80. We see what is this value. That equation, right? Yes. So for this equation, we can see this magnitude is the 0.8. 4/5, and minus for this one, that is say 16, 15. So for this one, this value is how much? So that is say 80, 64 minus 75. This one is less than 80 minus 9, okay? So for this case, that meaning for this data point, that means we have this equation is less than 1. Okay, so that means this point should be falling into the range here. So if you have any data points outside this range, then that means, for example, this point will make this equation greater than 1. As long as this equation greater than 1, that means the point is outside these boundaries. And in a similar way, this point has the equation is sigma 1 sigma uc minus plus sigma 2 sigma ut equal to 1. Okay, so we can check out the boundaries and then against the calculations. So probably here we can take a look at one